Hello students, this is our lecture number 3 in our chapter number 4 physics. The name of the chapter is motion in combined electric and magnetic field. Motion in combined electric and magnetic field is our topic of today. And the name of chapter is moving charges and magnetism. We have discussed about moving charges and magnetism in our previous chapter. So today we are going to learn about motion. We had learned the motion in electric field and in magnetic field. But today we are going to learn the motion in combined electric and magnetic field. The space where the combination of electric and magnetic field is present. If we put the charge over here, so what will be the changes in the motion of charge? So we are going to learn about that topic. So this is our schematic diagram. Here we have three axes. This is our x-axis, y-axis and z-axis. So the velocity is in x direction, the electric field is in y direction and the magnetic field B is in z direction. So the force, electric force is in y-axis direction and the magnetic field is in opposite to the electric field. So the electric field, the electric force and magnetic force are in opposite to each other. How it is possible? So we learn here that velocity selector. How can we select the velocity of a particle? We are using in a nuclear thermal power station or nuclear power station. So in nuclear power station, a neutron is bombarded on a heavy nucleus. So we cannot see without microscope a neutron. So the neutron is, how can we throw the neutron on nucleus? So the device which is used for accelerating these small particles is called cyclotron. So the cyclotron is the device which is used to accelerate the small particles for bombarding on a heavy nucleus. So the velocity of that particles is to be selected. How can we select? So this is the topic, that how can we select the velocity of a particle. So velocity selector, so as we know, the force equal to electric force plus magnetic force. We have both the formulas. The formula of electric field, electric force plus magnetic force. Formula of electric force is Q into V and the formula of magnetic field is Q into V cross B. That is the formula of a magnetic force. So this, here we have both the forces present. So we have written here that F equal to electric force plus magnetic force. So if we suggest the direction of that field, so the electric field is, electric field direction of electric field is in y direction. So as we learned in our standard 11, that x-axis direction is denoted by I caret, y-axis direction is denoted by j caret, and z-axis denoted by k caret. So the direction of electric field is in y direction, so it is denoted by j caret. So here E equal to j caret. Magnetic field is in z direction, z-axis direction, so it is denoted by k caret, and velocity is in x direction, so it is denoted by I caret. So I, j and k caret means it is in the direction of x axis, y axis and z axis. So here we have magnet electric force Fe equal to Q into E, but the direction of electric force is in y axis direction, so it is denoted by Qe into J caret. Now the magnetic force is in opposite to the electric field, so Q into V cross B. So here direction of V is in x axis, so it is denoted by I caret, and direction of magnetic field is in k caret, so it is denoted by B into k caret. So as we have learned in our standard 11, I cross j equal to k caret, j cross k equal to I, and k cross I equal to j. But here we have inverted. It is not k cross I, but here it is I cross k. So it is denoted by minus j caret. Here I cross k equal to minus j caret. So we have the magnetic force equal to minus qvb into j caret. So this is our velocity selector. Therefore, total force equal to electric force plus magnetic force. So we have the value of electric force and magnetic force. It is put here. So we here Q is common. So Q into bracket E minus Vb into J caret. This is our total force and its direction. So now, as electric and magnetic fields are in opposite direction, as we have seen that electric and magnetic fields force are in opposite direction. If we adjust the sum magnitude, if we adjust in such a way that the magnitude of electric force and magnetic force will be same, if these both value will be same, so the same magnitude minus same magnitude equal to 0. That means these both force will be equal. So we can write that QE equal to Q into VB. If the value of QE J caret and QVB J caret is same, that F equal to 0. So if minus QVB will change the direction, so QE equal to QVB. So we can write here QE into QVB. Here Q and Q will be cancelled, so we have E equal to V into V. So if we change the direction of V, so V will be go into the denominator. So V equal to E upon V. This is our velocity selector. So we should use the velocity of the particle is near about E upon V. E is magnitude of electric field and V is the magnitude of magnetic field. So the particles with speed E upon V pass undeflected through the region of crossed field. Here crossed field means the fields electric field and magnetic field are perpendicular to each other, so that it is called crossed field. Here magnetic field and electric field are in perpendicular to each other, so it is called crossed field. This method was employed by J. Thomson. This method of finding the velocity of the particle is invented by the J. Thomson. The name scientist is J. Thomson in 1897 to measure the charge to mass ratio. It was employed for measuring the value of ratio of electron to mass or electric charge or charge to the mass of an electron. So the principle used in spectrometer, this principle is used in spectrometer to identify the charge. So this was the velocity selector. How can we select the velocity of a charged particle? So by using this formula V equal to E by E, we can find the value of the velocity of a charged particle. Now if we go forward, the topic is cyclotron. We have to use this formula in cyclotron to find the velocity of a particle. So as we learned before, that cyclotron is a device to accelerate charged particles to high energy. So the speed of the particle will be higher than before. So to accelerate the particle, we are using now a cyclotron. Cyclotron was invented by two scientists, E.O. Lawrence and M.S. Livingstone. These two scientists were discovered. The cyclotron was discovered by these two scientists, E.O. Lawrence and M.S. Livingstone. If we go forward, this cyclotron uses both the fields, electric field as well as magnetic field. These both fields are perpendicular to each other in cyclotron. The particles move most of the time inside two semicircular discs like metal. Containers D1 and D2 are called discs as they look like letter D. If we talk about the construction of a cyclotron, here we can see that here two semicircular letter D type container we can see here. This is our 1D and this is our second D. So the shape of that container is like a letter D. So it is called Ds. Here we are using two Ds. It is used to travel the particle in a circular shape. Here these dots are suggest that the magnetic field is coming out of the paper. It is denoted by dot. And if the field is going inward to the paper, so it is denoted by cross sign. Here we have deflector point. If we put here at point P, P is our center point. So if we put the particle at point P, so the particle will experience an electric field and magnetic field. So with the help of electric field, the particle experiences a force. So it will go into one of the discs. As we go inside the disc, the magnetic field will change its direction of traveling. So that will fill a semicircular direction. So the path of the charge will be semicircular. As the particle comes out from one disc, the sign of electric field and the sign of both the discs will be changed. So the particles will go into the second disc. Once again the particle comes out by traveling semicircular path and it will be having a more energies. So it will increase the radius. The radius of the particle is increased by electric field. So the electric field is increasing the radius and energy of the particle, and magnetic field retains its path in a circular. So the path of traveling will be in a spiral shape. As the radius is keep on increasing, the one time will come that the particle will comes out of the cyclotron, and here we have a Here we have the target on which the particle is to be bombarded. So here, as we have the spiral shaped path, the particles will come out from reflecting by this plate. So this was the construction of a cyclotron. Every time particle is accelerated and the radius is increased, path will be spiral. Wall assembly is evacuated to minimize the collisions. This wall assembly is evacuated because of to minimize the collisions between ions and charges. So if we talk about the time, so time t equal to 1 upon v. V is the here Vc equal to frequency of cyclotron. So the frequency equal to here the formula 2 by m upon qb. This is the formula of v, velocity 2 by m upon qb. So Vc is equal to the frequency of cyclotron equal to qb upon 2 by m. So Vc is called cyclotron frequency. So if you are said in the examination that derive the formula for a frequency of a cyclotron. So this is the formula of frequency of a cyclotron, Vc. So if you call in 2 marks, this question can be asked in the examination that derive the formula of cyclotron frequency. So you can start from here that the derive the formula of a frequency of cyclotron. So you can start from here and you can end over here. So this is the 2 marks question, derivation of a formula of a frequency of cyclotron. This was the question of 2 marks, and this can be also asked in the examination. How can we select the velocity of a charged particle? Or else you can be asked in this way. Derive the formula for motion in combined electric and magnetic field, or how can we select the velocity of a charged particle. So this was the common construction of the cyclotron. In our next lecture we will go forward from here that how can the cyclotron is run and how it is work. So this was the common 2 marks question. First question is also this is 2 marks. So this is also 2 marks question. This is the common figure of a cyclotron. You can draw this figure into the examination. So this is the common introduction of a cyclotron. One thing you have to remember that the cyclotron is a common device which is used to accelerate or increase the energy of a charged particle. If you want to bombard the charged particle on any target, so you have to accelerate or energize it first. So that and then you can achieve your goal here. So in our next lecture we will go forward here.